Probability Theory for Teachers. Presenting EDOC 608 Group 3.
Hi everyone, my name is Edward Amis Bulangis, and today I'll be discussing to you the probability of independent events. Alright, so let's go ahead and start, but before anything else, let's first define what is or these two terms. So I have here first the compound events, and the second one is the independent events. So let's first define what is compound events. Compound events, these are actually made up of two or more simple events. An example of this would be, let's say, what is the probability of rolling a 6 on a 6-sided die? So I have here an image of a die, and of course we know that a die has a die has 6 faces. So 1, 2, 3, 4, 5, and 6. So again, going back to the question, what is the probability of rolling number 6 or 6 on a 6-sided die? Of course, the answer would be 1 over 6. So again, that's compound events. So these are made up of two or more simple events. Moving on to the second term, we have here independent events. So what are independent events? So these are compound events in which the outcome of the first event doesn't affect the outcome of the second one. For example, I have here fork and knife and spoon. So we have here number 1, picking a fork out of the silverware drawer and then replacing it, and then picking up a spoon again. So since the fork is replaced, then the probability of picking a spoon is not affected. So again, that's independent event. So what are independent events again? So these are compound events in which the outcome of the first events really doesn't affect the outcome of the second event or the second one. So since we're already done defining these two terms, so let us move on, let's say, how to find the probability of independent events. So we have here in words the probability of event A. Let's say there are two events. So we have event A occurring and event B occurring is the product of the probabilities of event A and event B. So we have here an image, A times B. Event A multiplied by event B. Remember, it's product. So that's the probability of event A occurring to event B. And when we say in algebraic terms, or algebraic expression, so we have here P, A and B, or the probability of event A and B equals the product, or P of A times P of B. So again, we multiply these two events, event A and event B. In other words, in finding the probabilities of the events separately and multiply the probabilities together. So the keyword there is product, or we multiply the two events A and events B. Alright, so that's how to find the probability of an independent event. Now, let's look at some examples. So, let's say we're gonna be rolling some dice. So we have here, find the probability that you will roll a 6 and then a 5 when you roll a die twice. So we have, imagine yourself, you're holding two dice, and we're trying to find 6 and at the same time 5 when we roll a dice twice. So of course, remember the keyword, we need to multiply the two events. So we have event A, which is the probability of getting number 6 or 6 face, times or multiplied by the probability of getting number 5. So how many faces do we have in a dice? Remember, it's 6. So probability of getting 6 in a one die, so we have 1 over 6, multiplied by getting the probability of 5 in a die, which is still 1 over 6. So multiply 1 over 6 times 1 over 6. So let's say 1 times 1, that's 1. And then 6 times 6 equals 36. That means there's only one chance out of 36 tries in getting numbers 6 and 5. Simple, right? So yeah, let's try another example. So we have here, there you go, marbles. How about an example, marbles? So a bag contains, let's say a bag contains 3 red, and then we also have 4 blue, and then 6 yellow marbles. So imagine we do have 3 colors in the bag, 3 red, 4 blue, and 6 yellow marbles. One marble is selected at a time, and once a marble is selected, it is replaced. So we have here the given or the question, find the probability of getting 2 yellows. So we have P of y, the probability of getting a yellow, times the probability of getting the second one, which is still yellow. So how many marbles do we have? Remember, we have 3 red marbles, 4 blue marbles, and 6 yellow marbles. So a total of 13. So we need to get yellow. So the probability would be 6, since we have 6 marbles in yellow color, over the total number of marbles that we have, which is 13. So 6 over 13 times, same, remember, it's the same thing, yellow. We're looking for the probability of getting yellow. So 6 over 13 times 6 over 13. So 6 times 6, that's 36. And 13 times 13, so we have a total of 169. So the answer would be 36 over 169. So let's move on the second example about marbles. So we have, find the probability of getting blue, red, and yellow. So still, we use the same formula that we have used earlier. So probability of getting blue times the probability of getting red, and probability of getting yellow. So P of B times P of R times P of yellow. So how many blue marbles we have? That's 4 over the total number of marbles, both yellow, red, and blue. So that's 13. So that's why we have there 4 over 13 times the red, probability of getting red, 3 over 13, times yellow, that's 6 yellow marbles over total number of marbles, 13. So we multiply 4 times 3 times 6, that's total of 72, over 13 times 13 times 13, that's a total of 2,197. So our final answer would be 72 over 2,197 is the probability of getting blue, red, and yellow. Alright, so I believe that's clear to everyone. So it's now your turn to answer. I have actually prepared few questions. It's an online quiz. All you need to do is to type the link below in a new tab, and then you need to answer the question on compound probability of independent events. So that's https://quizzes.com/join?GC equals 22402589. And we'll be checking your answers afterwards. I'll be giving you 5 minutes to do that, okay? Alright, so we'll be seeing each other again on our next topic that I'll be discussing. And thank you so much for watching. Have a great day.